Hi, welcome back to Alien Space Education. My name's Andy. I'm your host of this amazing exploration of our galactic area. Today's episode is on Uranus, our tilted ice giant. Before we begin, I'd like to say thank you for listening. I hope you're enjoying these, and I will keep going. Don't forget to share, like, and anything else you can help support and share the love. Okay, let's get straight into this amazing, unusual planet. Uranus, the basics. Uranus is a gas giant, even though it has a solid core, but its distance from its larger sibling Jupiter and Saturn, due to its icy composition, is often classified as an ice giant, along with Neptune, reflecting its difference in composition. Uranus is about 50,724 kilometers in diameter. That's approximately 31,518 miles, making it the third largest planet in the solar system. Uranus' atmosphere is composed primarily of hydrogen and helium, but also contains significant amounts of water, ammonia, and methane. The presence of methane gives Uranus a distinctive blue-green color, as methane absorbs the red light and reflects blue-green wavelengths. So this is an experiment you can do at home. If you have a light and you put it through a prism, you get a different reflection. You'll see the rainbow reflected. But what absorbs that light and what do you see back? So if you use different filters, you'll see different wavelengths and different colors you won't do. So it's an interesting way to do this. One of the most striking features of Uranus is its extreme tilt. The planet is tilted on its side by about 98 degrees relative to its orbit of the Sun. This means Uranus essentially rolls along its orbital path, with its poles facing the Sun and the equator lying nearly parallel to its orbit. This is a unique tilt resulted by extreme seasonal variations, with each pole experiencing about 42 years of continuous sunlight followed by continuous darkness. So basically, Uranus, we're about there. Uranus is here, 90 degrees, 98 degrees, so it's slightly over. And it's rolling, constantly rolling on its side, going round and round and round. But 42 years darkness, 42 years light. So it's constant. So why does it roll round rather than stay upright? We're not 100% sure. But because of its extreme length, the Uranus orbits the Sun at an average of about 9.2 billion kilometers or 1.8 miles, which is about 19.2 AU. So you got to think, Earth to Sun is 1 AU. It's 19 times the distance from the Sun to Earth. So we remember astronomical units, that's how they're worked out. So it takes about 84 years for Uranus to complete one orbit around the Sun. So its year is 84 Earth years. Its planet's day is relatively short, so it spins highly fast. Not as fast as Jupiter and Saturn. Its day lasts about 17.2 hours. Not the 24 that we need, not as fast as Jupiter and Saturn. Its atmosphere. Uranus' atmosphere is one of the most intriguing aspects of the planet due to its unique composition and weather patterns. The atmosphere is primarily made up of hydrogen, about 83%, helium, about 15%, and trace elements of methane, water, and ammonia. So there is a big gap there, even 15 plus 83. There's still that huge percentage of methane, water, and ammonia. That's a lot that's going to make up the remaining percentage. The presence of methane is responsible for Uranus' blue-green color, as mentioned before, as it absorbs the red light and reflects blue-green. This correlation makes Uranus stand out among other planets, giving it a serene icy hue. So it makes it look really cool. Uranus weather is characterized by its cold temperatures. The planet is one of the most coldest in the solar system. Its temperature in its upper atmosphere dropping to minus 224 degrees Celsius or minus 371 degrees Fahrenheit. This frigid environment is due to its distance from the sun and lack of an internal heat source. So there may be something heating in the middle, but it's not reaching the outer edges. But because it's so far from the sun, it's not getting the solar radiation, the solar heat to keep it warm and trap that heat in. Despite its cold temperature, Uranus does experience dynamic weather patterns. The planet has been observed to have high-speed winds reaching 900 kilometers per hour or 560 miles per hour. These winds create dark, narrow bands of clouds that are thought to be composed of methane and other gases. So, as fast as it spins, like we get layers, just like Jupiter and Saturn, we have different layers for different things. And because it's blue, we just see a blue ribbon. But the faster they spin, obviously, that changes the colour. Uranus weather system also includes storm systems. Observations from the Voyager 2 spacecraft and the Hubble telescope have revealed large storm systems and bright clouds within its atmosphere. These storms appear to be driven by internal heat and the planet's unique tilt, which causes seasonal changes and astronomical dynamics. So even though it says it lacks heat, there is heat. It is producing some sort of weather pattern, but it's changing. And we're not sure because we monitor the Earth's weather, because we're here, we can see it. To measure the weather patterns on something so far away and to get the internal looks, we're not capable of that yet, but we're working on it. One of the most fascinating aspects of it is of Uranus's atmosphere is its cloud formation. The planet has a complex system of clouds that vary composition and altitude. The uppermost clouds are made of methane ice, and the deeper clouds contain ammonia and water. These clouds contribute to the planet's distinctive appearance and weather patterns. So we've got ice, methane ice, in up high. We've got water lower down. So that ice has to melt to come down. So what's producing the heat to melt that, despite the fact it's so high? And those cloud variations give the planet a very huge thing. And don't forget, these clouds are spinning at 900 miles an hour. The wind getting blown around. So it's very unusual and needs a lot of looking into. One of the other things that Uranus is really, really good for is it has rings as well. Uranus has a system of rings, although they are less prominent and less well known compared to the stunning rings of Saturn. The rings of Uranus were discovered in 1977 by an occultation event observed by the Khyber Airborne Observatory, when the rings passed in front of a star and the starlight was momentarily blocked, revealing the presence of these fake rings. So back in 1970, we were looking at it and it went, there's a star, and we went, meow, and it disappeared. And we went, why did that happen? And that helped us observe it. Now, if you look at some images of Uranus, you'll see that we have actually seen them, and they are very dark, but they are there. The rings of Uranus are composed of dark, narrow particles that range in size from micrometers to several meters. They are much darker than the rings of Saturn and are thought to be made up of a mix of ice and rock particles. These rings are divided into several groups, each with distinct characteristics. Now, just like Saturn, these rings have been label, we've got the Epsilon ring. This is the brightest and widest of the Uranus rings. It is relatively narrow but stands out due to its high reflectivity. The alpha, beta, and gamma rings, these rings are narrow and darker than the epsilon rings and are located closer to the planet and are less reflective. Then we have the delta ring. This is the faintest ring, which is located further from the planet. It is a very narrow ring and is difficult to observe. These rings are thought to be relatively young, possible from debris after a collision with the moons or other objects. The gravitational interactions of the planet's moons play a significant role in maintaining the structure of these rings. Some of the moons of Uranus act as shepherd moons, helping confine the particles within the rings and prevent them from spreading out. So the moons are really, really important. And if you've been following the news recently, you will see that actually, due to the James Webb Telescope, we actually had a look. We've actually discovered a new moon as well because we've been able to get a better look at Uranus itself. Uranus and moons itself are an intriguing system. Uranus has a diverse collection of moons. With 27 known, 28 now, that 28th has got to be confirmed. Satellites ranging in sizes from small to moonlets to large ice bodies. And we're going to explore some of the most intriguing ones. Okay, Miranda, one of the most intriguing moons, is the smallest of the 5 major moons. It has a surface that appears to be a patchwork of different terrains. Miranda's surface features a mixture of extensive canyons, ridge-like structures, bright, smooth plains. The moon's unique appearance is thought to be the result of intense geological activity and resurfacing process. So it's like inside that's changed it, so just like earthquakes and other things we have here on Earth, but also resurfacing process. Gravity could have played a massive part of this because it's next to such a giant planet, but also it could have been impacted by other objects, meteors and asteroids. So we don't know fully what it is, but it has made it really, really interesting. It's really cool. Next we have Ariel. It's the second largest moon to Earth's surface that shows evidence of extensive faulting and cratering. Ariel's surface is covered with a network of grooves and valleys, suggesting a history of tectonic activity. The moon is also bright, icy regions. This may compose of water ice. So we're talking about extreme faulting, so earthquakes again, as it's mentioned, cratering, so it's been impacted heavily. These grooves and valleys show that it's been pulled apart somewhere and changing, but there's also water ice there. That's interesting, because we know Uranus has water ice in the atmosphere, so that could have come from that. But why is it still held onto it? Why is it still there? Why hasn't it evaporated up? Or why hasn't? Could there be life on there that we don't know? Because that's what we need. We need to learn more about Ariel. Next we have Umbriel. This is one of the darker moons and has a heavily cratered surface. It's less geologically active compared to Miranda and Ariel, with a surface covered in impact craters and a few signs of resurfacing. Ariel's dark appearance is due to a thick layer of dark material, which may be a mix of carboniferous compounds. I apologize if I said any of this wrong. So, Umbriel, it's heavily cratered, so it's been impacted a lot. And as these impacts happen, just like if you drop a stone in the sand, it changes what's around it. And if it keeps changing, it's going to have an ongoing impact. So, and we don't know if that's had a geological impact. We don't know if there's earthquakes and things like that, but it seems to be less active because it's been hit so many times. So we don't fully know, but there's a lot to learn about Umbral. Tatiana is the largest moon of Uranus. It has a diverse surface with a composition of cratered regions and grooved terrains. The surface terrain features a large fault system and evidence of past geological activity. Tatiana's size and complex geological makes it a key target for future exploration. So because it's large, it makes it a lot safer for us to explore it. But because it's got cratered regions, means it has been impacted. Grooved terrains means there is some limited geological activity. But when we say limited, it means it could be limited now, but there has been, in the past, it has been heavily geological activity. So something has slowed down that geological activity. What? We don't know, but that's something we're looking into. And that's why we want to explore it more. Next, we have Oberon. This is the second largest moon and has surface covered with a mixture of craters and bright icy regions. Oberon surface features similar to those of larger moons of Uranus, with a combination of impact craters, geological features that suggest past tectonic activity. So Oberon was, and we do know, was very heavily active. But now, because it's had a lot of craters, we're wondering if the activity was because of the craters or because of gravity causing a force on it that made it the way it is. When we're still looking at it, and there's still a lot to learn. Each of Uranus' moons offer unique features that provide valuable insight into the history and the evolution of the planet's satellite system. So, by studying the moons, we find out what's happening on the outer, what's happening around Uranus, which might help us explain why Uranus went boop onto its side. So that's why it's really, really important. Looking at Uranus in more detail, Uranus has only been visited by one spacecraft, NASA's Voyager 2, which conducted a flyby of the planet in 1986. Voyager 2 provided the first and only up-close images of Uranus and its moons, revealing much of the planet's atmosphere, rings, and satellite system. During the flyby, Voyager 2 discovered Uranus rings and provided detailed observation of the planet's atmosphere and moons. The spacecraft captured the first up-close image of the planet, unique tilt, and its ring system, as well as a detailed surface features of Uranus' major moons. The data collected by Voyager 2 has been instrumental in shaping our understanding of Uranus, but since then no spacecraft has visited the planet. Future exploration of Uranus could involve sending a dedicated mission to study the planet's atmosphere, rings, and moons in greater detail. One of the proposed missions is Uranus Pathfinder, which could include an orbital study, the atmosphere, its rings, as well as a probe to analyze the atmosphere and potential lander or atmospheric probe to explore the moons. Such a mission would provide valuable insight into the icy giant and help us understand its role in a broader context of planetary science. For now, the exploration of Uranus remains a priority for future missions, and scientists continue to study the data of Voyager 2 and to learn about the intriguing planet. The continued advancements in space technology and missions planning will hopefully lead to new discoveries and deeper understanding of Uranus and its planet and its place in our solar system. As we know, James Webb has had a look and changed things. This mission could be crucial to finding out more, but everything we know is from 1986. That's why James Webb and other telescopes and other scientific can look, but we can't get more detail. And that's what we're working on. And it does mean there is a lot to learn. There's a hell of a lot to learn. And as we know, James Webb, just by looking at it for a short period, discovered a new moon on its own. So what else is Uranus hiding from us? What else can we find out and learn? As we conclude this exploration of Uranus, it's clear that this icy giant planet and the remarkable uniqueness and scientific history, and from its extreme tilt to its icy composition to its fascinating rings and diverse moons, Uranus continues to captivate the imagination of astronomers and space enthusiasts alike. All of us, we love it. The study of Uranus is not only enhanced our understanding of the outer solar system, but also provides valuable insight into the formation and evolution of the planet Sirius, as well as looking forward to future missions and discoveries. Uranus remains a key object of interest in our quest to unveil mysteries. I really want to say thank you for joining me. I really do enjoy doing these, and I'm sorry I'm not keeping up as well as I should, and I will keep doing it. So if you enjoyed the journey of the ice giant, be sure to subscribe, rate, leave a review. In our next episode, we're doing the final large planet, Neptune, before we go on to other things and delve into its dynamic atmosphere and intriguing moons. Until then, stay curious and remember, the universe is full of wonders waiting to explore. If you have any questions and want me to explore them, please get in touch. Share, like, do whatever you need to do. I am here. I will keep doing these as best I can, and I look forward to hearing from you soon. Please keep enjoying. Thank you for joining us today.